Okay. First one, you know what I'm going to do? I'm going to throw that as a 3 over a 1. And I'm going to put this as a 1 over 1. Okay, I'm just looking at this top part. How do we add those together? What's the common denominator between a 1 and a 6? 6. What would you have to do to this first fraction? You would have to times the bottom by 6. To turn the bottom into a 6, you would have to multiply it by 6, so 18. What would you have to do to the second fraction? The bottom is 6. You don't have to do anything to change it to 6. So don't do anything to the top. Okay, so that's done. The top is done. Now, let's go to the bottom. What do I use as a common denominator there? 8. What do I have to do to the first fraction? There was a 1 on the bottom and now an 8 on the bottom. So I'll have to times it by 8. On the second fraction, I had an 8 on the bottom and I have an 8 on the bottom, so I did nothing. Okay, so this is going to simplify right now just to 19 over 6 divided by 5 over 8. See where I'm getting those? I'm just going 18 plus 1 right now, and the 8 minus 3. Okay, so that was how to add. So that was what we did yesterday. Today is how to multiply and divide. So I'm going to take the first fraction, instead of dividing, I'm going to multiply and flip. You understand how this is written? Fraction divided by fraction. Okay, we just did it the last time. I just made it look like that. Okay, that's what I did. That was the same way. Okay, when you look at this, is there anything you can cancel out? There is something. I can divide the top and the bottom somewhere, both by a 2. So if I do that, the 8 becomes a 4 and the 6 becomes a 3. That's it, because I know 19 is a prime number. So 76 over, you can do that one in your head. What's 3 times 5? 15.
Dividing by 2 with those 8 and 6 is just like saving you from reducing your fraction later?
Yeah. Because if you would have just done it, you would have got 152 over 30. And then you're like, oh, does that... It's easier to see it there than there. Okay. Kind of this is the setup. We're going to have a fraction divided by a fraction. Okay, I'm going to look at just the top. There's an 8x and a 1x. So what do I need in my common denominator? 8x. Okay, don't use 8x squared. Yes, it is a common denominator, but it's way higher than you need to go. Again, it's like between a 4 and an 8, picking like a 32. You don't need to go that high. You're always trying to get the lowest one it fits into. Okay, so the 4, I'm going to have to do nothing to it. And the second fraction, I'm going to have to multiply by 8. Okay, now I'm going to look at the next part here, the bottom. So there's a 4x and a 2x. Think about the smallest thing you could put them both into. Did you go with an 8x? Okay, and again, 8x squared works as a common denominator, but it's going to make your math way too complicated if you go too high. Okay, so what am I going to do to the first fraction?
Did you just do 4?
Oh,
4x?
yeah, sorry. As I'm preaching to not pick big and then I picked something bigger. I was thinking ahead to something else. Shouldn't do that. I'm like, don't do that, and then I do it. Okay, so I'm picking 4x. So I'm going to do nothing to that, so 3. And then this is going to be times by 2, so minus 2. Okay, so I'm going to make this a 20 over 8x. We're okay with that? I just put the 4 and 16 together. Are you okay if I already times and flip? Times. I'm going to put the 4x on the top, and 3 subtract 2 is 1. Okay. Now that I'm there, now I can look for cancels. So x can just go. And we can divide what? What do you want to divide by?
By 4.
A 4. So I'm going to go like this. Cross off 4. 8 turns into a 2.
22 will be divided by 2.
So it's kind of hard to see, but this is what I have left. And then I can divide that. So 20 and 2 can become 10 and 1, or 10. Okay, let's try these last two. Okay, so we have a 3 and a 3x. So my denominator will be 3x. Okay, what am I going to do to the first fraction? How did I change the 3 into a 3x? I'm going to have to multiply by x, creating x squared. On the second fraction, 3x is 3x. So I don't do anything. So just minus 9. Okay, let's take a look at the bottom. So this is a 3x and this is a 3x. So let's just use 3x. Which means I don't have to do anything or anything. Okay, so now I'm going to rearrange that with the flipped multiply situation. Okay, so that's what it looks like when it gets all flipped around. Now I look for cancels. So 3x and 3x can actually both cancel like that. Now there's something else I can do. Difference of squares. So after I've done that, can I look further and try to cancel? X plus 3. So what am I left with? X minus 3. And it's on the top, so we don't have to do the 1 over or anything. Okay, I feel like I often get the mistake of people trying to think they can cancel like that. You can't. You can't cancel adders. What did I say? You can only cancel things when it's this times this times this divided by this. You can only cancel like that. You can't cancel like that. Okay, last one. It's very similar to this example. Okay, so I have an N and an NM. I picked some bad letters here for talking. What's my common denominator going to need to be? I need an NM. Okay, so what did I do to the first fraction? How did I turn that into that? I times it by an m. So m squared. What did I do to the second fraction? Nothing. So minus 16 stays. Okay, let's look at the bottom. We have an n and an nm again. So nm. What did I do to the first fraction? I times it by an m. So m. What did I do to the second fraction? Nothing. So minus 4. Okay, so if I do the flip multiply, okay, can you finish this one out? It's the same as last time. NM will cancel. This is a difference of squares. So I can factor setting myself up with this times this divided by this. And once I have a situation where everything's times or dividing, I can cancel.